Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'd like to go over Physics 132, Test 2 from fall 2009, Part B, which is dealing with Chapter 30 material from Knight, Potential and Field, and in particular Section 30.3, Finding the Electric Field from the Potential. So, first let's carefully read the question. A large, flat, conducting plate is grounded so that its electric potential is 0. A nearby small conducting sphere is held at an electric potential of 25 volts. The shortest distance between the edge of the plate and the sphere is 6 centimeters. A midway point P is 3 centimeters away from the plate and 3 centimeters away from the sphere. The situation is shown from the side in the sketch below. And scrolling down, there's 3 parts to this question, worth 2 points, 1 point, and 3 points. The first part is estimate the electric potential at the point P. Second part is what is the direction of the electric field at point P. Circle the best choice from the following 6 possibilities: left, right, up, down, into page, or out of page. And finally, it says estimate the magnitude of the electric field at point P. Okay, so there's a couple of things going on here. You've got a conductor in electrostatic equilibrium, so that's chapter 30.4, and there's a nice little figure on page 921, figure 30.20, which is estimating the field and potential between 2 charged conductors. Basically, the potential lines are parallel to the surfaces of the conductors, and when you're finding the electric field, it points from high potentials to lower potentials, and it's always perpendicular to the equipotentials. And if you want to find the magnitude of the electric field, you take the difference between two equipotentials, and divide by the distance between them. So let's look at the solutions. Okay, so looking at my solutions, the first thing that I've done is drawn on this diagram. I've drawn the equipotentials as we would measure with a voltmeter. So near a conductor, they're going to be parallel to that conductor, because the conductor surface is an equipotential. So this is going to be an equipotential of 25 volts right here, and near it, it's going to go down. So, and over here, this will be an equipotential of 0 volts. This is B equals 0 because it's hooked to ground. And we can imagine that these would start to flatten out, and they would form sort of circles around here. And maybe we could call this, if this is 25, this might be 20, 15, 10, going down to 0 volts. And the electric field will be perpendicular to the equipotentials and pointing from plus over down to minus, towards lower potentials. So if we wanted to estimate the electric potential between here and here, we would say it's 25 volts here, it's 0 down there, so about halfway in between, might be somewhere halfway between 25 and 0. Now technically, I think the equipotential lines might be closer together towards a curved conductor like this, as they would be more further spaced out when they're near a parallel plate. So it might be a little bit closer to 0 than it is to 25, but just as rough estimate, something like 12, 13 volts. As for the direction of the electric field, it's going from plus to minus, so it's definitely towards the left. And as for the magnitude, we did this in practicals. To find the magnitude of the electric field, you take the difference in potential at 2 points and divide it by the distance. So 2 points we could choose here would be just on either side of point P. We know it's 25 here, it's 0 there, so delta V is 25. And we know it says that it's 6 centimeters is the shortest distance between the plate and the edge of the sphere. So 0.06 meters is 6 centimeters. Plugging that into my calculator, 420 volts per meter. So something like that. Another unit for electric field is newtons per coulomb. It's the same unit in SI. So that's it. It's testing your understanding of connecting electric field with electric potential, and also how well you remember doing activities, activity 8 and 9 from the second E&M, or the third E&M module, in which you're actually measuring potential with a voltmeter and then determining electric field from that. My name is Jason Harlow, and I approve this message.